Hello friends, in this video tutorial we're going to learn about the most interesting topic in the geometry, which is the conic sections. So first of all, let's begin by constructing a cone. Okay, so to construct a cone there are various elements. So the first thing which comes is that make an axis we make an axis and then we take a generator line. So let's start by marking things. Now it will be easier to understand then. So this is called an axis. Let's elongate it. Then we have a generator line. Let's say this is the generator line which makes an angle alpha with this particular axis. So what happens is that we rotate this particular line, the generator line, about the axis by keeping this angle as constant, so that if you work out will generate, so it will be a bicone as shown here. So there are various elements which will occur. First one is that there will be two cones which will be formed. So the individual cones are called nap. This is called the upper nap. This is called the lower nap. This is called the vertex of the double cone, and this is called the angle of the cone. So as you have seen that the name of the chapter is conic, and so conic section. So we'll be studying different sections. So what do you mean by that section? So let's now look into. Okay, so these are basically how we construct a segment of or a section of the cone. So we have generated the cone, and the we'll take a plane and make different sections which occur at the intersection point of these two particular figures, that is the plane and the cone. So the intersection gives us different types of conics, which are like parabola, circle, ellipse and hyperbola. So let's look into how each of these is generated. So there are two important characteristics to note. First is the angle alpha, which is called the generator angle, and the second one is the angle of the plane at which the angle at which that is the angle made by the plane with the axis. And as you recall, axis is this. Always the axis will be a point passing through this circle center, this vertex and this circle center. So the angle made by the plane, let's consider it as beta, are the two important characteristics to note which type of the conic is formed. So let's look into, say if we have beta equals to 90 degree. Okay, before starting this, I like to mention here is that first of all we are considering the cases when this plane doesn't pass through vertex. We'll discuss the other part later. So the first thing is that these planes won't pass through this vertex right now. Okay, so if the now we'll consider the cases individually, that if the angle at which the plane cuts the cone is 90 degree, that is beta is equal to 90 degree, then the type of the section or the conic which is formed is a circle. So as you can see, this is the axis. For a plane to cut the double cone at 90 degree, we'll have this particular circle which will come out as at the intersection of boundary of these two particular figures. So note here that if beta is equal to 90 degree, then we will obtain a circle. Similarly, for the next one, if we have the angle beta lying between 0 to 90 degree, that is it's not parallel to the axis and not perpendicular to the axis as well. It makes a certain angle with the it makes a certain angle with the axis, that is, so if beta lies between 0 and alpha, we'll obtain an ellipse. That is it's neither parallel to this generator line, that is this is the generator line, it's neither parallel to generator line, it makes a certain greater angle than this particular generator line. So we'll obtain an ellipse here. And the next thing we'll discuss is that of the parabola. When we have the plane, the angle beta equals to alpha, that is this particular plane, this plane is parallel to this generator line. So as you will note that if it's parallel to generator line, we'll have two particular we'll have the cone intersecting the plane only at a single point, that is insertion or say deletion types. So we'll have only a cut here. So this particular thing is called parabola. So let's note down here, if beta is equal to alpha, then we have parabola. The next part is if the angle beta lies between 0 to alpha, that is either it's parallel to the x-axis or makes an angle less than alpha, that is the angle less than the generator angle, we'll have an hyperbola. If you are not currently getting the feel, just follow a simple the simple instructions, and you will be able to feel later on what the type of figure you are obtaining. Just get used to these rules, and you will be able to learn later on about the actual shape which comes about when we draw these types of conics. Therefore, let's now talk about the case when the particular cross section of the plane passes through the vertex of this particular cone. So we had earlier 4 cases, that is when the angle beta that is made by the section plane was equal to, in the second part is called the degenerate cases. We may not be dealing with the degenerate cases in the later part of this video tutorial, but let's look into to get a feel of the degenerate cases, that is when the plane passes through this point, that is vertex. So in that particular case, just we have only 3 cases, that is when alpha that is less than beta and beta is less than or equal to 90 degree. Then we have a point as the point of intersection, and there's no particular curve which is obtained. So we have, let's write it down, a point for degenerate cases. When beta lies between 0 to alpha, we obtain a pair of straight lines. And in the third case, when beta is equal to alpha, we obtain a single line which contains one of the generator lines. Single line containing one of the generator lines. Okay, so after we have distinguished between how these conics are obtained and what are these conics, let's first of all look into the simplest conic, which is obtained when beta is equal to 90 degree, that is circle. So the definition of circle is that a set of circle is a set of all points in the plane that are equidistant from a fixed point in the line. That is, this the fixed point. Let's take O as the fixed point, and the all the points equidistant from it represent circle, and the distance is equal to r. So all these points, that is boundary, is a circle which contains points p, x, y, which satisfies let's say if we have this O as or C as h comma k, then by distance formula we'll have the equation of the point P as satisfying the distance formula as x minus h whole square plus y minus k whole square equals to r square. So in general, this particular thing is the equation of the circle. Next we move on to another simple conic, that is parabola. A parabola is defined as a set of all points in a plane that are equidistant from a fixed line and a fixed point not on the line in the plane. That is, to visualize, this is the simplest parabola which we'll take in general examples. So this particular blue line is the parabola and the fixed point, and as we have considered this parabola as centered at 0, 0. Here we have x-axis and the x-axis and the y-axis, and the fixed point is f, which is a, 0, and the fixed line that is called directrix, which is at a which is equal to x equals to minus a. So this is the fixed line and this is the fixed point, and we have this point as the vertex of the parabola. This is known as the focus, this is known as the directrix. So to get a general equation of this type of parabolas, we'll just use the basic definition. So let's write down the definition here. First of all, let's take the point p x comma y here and draw a perpendicular on directrix from point P to hit it at M. So the coordinates of M will be, it'll have the same y coordinate as point P, so it'll have the and the x coordinate as equal to minus a. So we'll have minus a comma y as the coordinates of M. So now calculating the distance of the point P from two points, that is M and from focus, we have x plus a is equal to under root x minus a whole square plus y square. Now squaring on both sides, we obtain x square plus a square plus 2ax is equal to x square minus 2ax plus a square plus y square. Cancelling out the common terms, we obtain the equation as y square equals to 4ax. These are the four general types of parabola which we'll take in our examples. They are the simplest ones, centered at 0, 0, and will have their directrix either parallel to x-axis or y-axis. So we have the first case in which the parabola opens upwards and has its directrix parallel to x-axis, y equals to minus p, and focuses at 0, p. In the next, and so its equation will be x square equals to 4ay. So this is the second type of the parabola which we'll consider. It opens downwards and has its directrix at y equals to plus p. It's given wrongly here. It's equal to plus p here, and this G point is at 0, minus p. Similarly, this is the parabola which we considered in our proof. We'll have directrix at x equal to minus p and the focus at 0, p. In this particular case, we'll have our focus at 0, minus p, and our directrix at directrix will be x equals to plus p, and the equation will be this. So just memorize these four equations and the corresponding curves, and it will be easier to follow the basic questions.